So, hello everyone, and welcome back. Continuing our learning in the series of generative AI, let's talk about how the text to image modeling works. So, in today's time, we have so many new models, or you can say we have so many new tools where we can simply write an input, and out of here, it can create image for you. Apple or be it Google, they have introduced, or Samsung, they have introduced this very basic feature within their gallery of photos that you can update, you can create new images. You must have heard about Stable Diffusion in case, or Midjourney is a very big, good platform in itself. So, how exactly do these platforms create images out of text? So, let's quickly dive into it and discuss how it works. So, for example, let's talk about Stable Diffusion. Stable Diffusion is a model that kind of creates an image out of text. So we can learn how stable diffusion works. So on the similar base, or you can say similar structure, is how other model also works. For example, it can be Flux or different models that are out there. So diffusion models, as the name suggests, it diffuses. So it has a straightforward learning method. So when a diffusion model is trained, it is trained on images. So for example, I will annotate or I will tag this image of a cat. What the model will do is it will keep adding noise to that image till it reaches to very noisy state. So how is the computer learning or the model learning? It is adding noise to the image and it is making this good image of cat go or convert into a complete noise state. Now, adding different noises to reach this state, the model start to learn what are the different aspects of a cat. So here, if we annotate hundreds or thousands of cats, like generally this all process happens on millions and a lot more of data across the internet. So because the database is high, the process is not very straightforward how I'm explaining, but still the first learning happens where the images are added noise and it gets taken to the most noisy state. Now, when the model has been trained, when we give it any image or when we give it a text out of something, it starts from a noise state. So we tell the model that, okay, this is, we kind of confuse, or you can say, because it is a device or it is a computer, we tell him, okay, hey, listen, this particular state is actually a cat. Now give me a cat. So what it does, it starts from a noise state and it starts to reduce little noise from that image and learns based on their learning on how the cat or what are the characteristics of a cat, they will remove the noise and create a cat. So if you annotate these images as dog, it will learn that it is a dog. So you need to be very sure about the data that you're annotating and training the data. So this is basically how all these images in the training process eventually gets converted to noise. But in this process, the system learns, right? So here, and it is exactly like this is your image, and you keep adding noise till it converts to a noisy state, right? So for now, what is reverse diffusion? It is when the model has been trained, it starts from a very noisy state, and it keeps reducing noise till the till you get the final result of a cat. So for example, it keeps removing noise, it keep adding details, and it eventually creates this image, right? So now, what exactly is training? So this is how the noise predictive training works, okay? And diffusion works in the opposite way. So this is my image, and if I predict some noise that I need to subtract from the image, I will get lesser noise image. The noise will keep reducing till we get a clear and good image of this. So this is how the diffusion or image to or text to image actually works, right? If I talk about one specific, these are more details into coding and how exactly you can make this work in a more smarter way. These are some solutions that we have eventually figured out, but I do not see any need for discussing all of this. So what happens is, if I tell you this is something important that we can learn is when we enter a text prompt, like create a cat, what happens is our text is converted into a token. Is converted each index is converted to token, which is embedded in the space. And using the text transformer, we predict the noise, right? So it is not as simple that our text is converted to image. There are multiple different models and other things which make our text in a way that the computer can understand it, and then it can identify images that matches to that particular text, and then creates the output and reduce noise to where we eventually reach. So it is really something very smart about the overall system. So I guess that's all for today. We wanted to discuss about these models, and that's all. So yeah, have a nice day.